All right. Good afternoon, Jordan, Patricia, and Jalen. So this is section 2.1, and it's going to be in three parts. So here's the first part. So um, this is a section on absolute values. So before I get to the definition of that, what I want to review with you is our number sets. Why? Well, this won't come into effect really much this section, but we're really going to look at it a lot next section. So I want us to keep this in the back of our minds. So when we talk about natural numbers, they're denoted with the big uber capital N, and those are our counting numbers. So it would be 1, 2, 3, 4, etc. Okay, no fractions, no decimals. Whole numbers are very similar to natural numbers. Actually, they are the natural numbers with one more additional number, which is 0. Okay, again, no decimals, no fractions. Integers are all our whole numbers along with negative numbers. So they're negative numbers, 0, positive numbers, just like the number line at the front of our classroom. So all of these, there's no fractions, no decimals. Whoops, no decimals. I'm not sure why integers are denoted with a Z. They just are. So now we have our rational numbers, so denoted with a Q. So again, I'm not sure why. Maybe because rational R was used for it. It probably has to do with the Latin word for rational, which I have no idea what that is. So our rational numbers are all of our integers, but they also include fractions. So our fractions have an integer numerator and an integer denominator. Okay, and what that looks like as a decimal is we'd see a terminating decimal. So that just means it ends. So it's not like 3.489877864 etc., right? It's something like 3.5 or 8.79 or something like that. So it also includes decimals with a repeating pattern. Okay, so something like 4.33333333. So we put a dot above the 3 to show the 3 is repeating, or something like 6.171717, where we put a line over the 17 to show that that's repeating. So those are rational numbers. Irrational numbers are the opposite of rational numbers. So they're numbers that they when we look at them, they're a decimal, but there's no repeating pattern in them. So we're not going to see a lot of examples of those right now. The biggest example would be pi. Okay. Another one is the square root of 2. Those are examples of irrational numbers. And then real numbers are all of these numbers we talked about. Okay. And all the numbers we're going to look at in Math 11. So now let's look at the top of the page. This is where we're going to talk about our new topic here, which are absolute value. Okay, so we denote the absolute value. It's a number between two big lines. So just like that. Okay, that's called the absolute value. So the definition of the absolute value is very similar to the magnitude of a number. Whoops. Meaning it's the distance the number is away from 0. And these will always be positive because again, when we're measuring things, we measure them in positive distances. So when we have something like the absolute value of -2, what that really means is how far away from 0 is -2. So we see here on this number line that if 0 is here, -2 is here, so it's 2 away. So we say the absolute value of -2 is 2. Similarly, the absolute value of 2 is also 2 away from 0, so its value is 2. So the shortcut to this is when you have one number inside your absolute value symbols and it's negative, the absolute value of that negative number is just the positive number value of that number. Okay, so now we are going to look at example 1. So, sorry, Jordan, this is the amount of space I have. There's no way that's my answer is going to fit in there. So I'm going to flip to a new page to do that. Which, this is the third time I've recorded this, so this will be the third time I've done this. Oh boy, what did it do? So I'm going to erase the answer here. You can look at it, but I guess it might be better if you can actually see me do it. So what we want to do is we want to find the absolute value of our numbers, and then we're going to order them by putting them in a number line. Well, I have 5 minutes. Okay, so here we go. So the absolute value of 4.2, again, how far away is 4.2 from 0? Well, it's 4.2. Ah, so easy, it's hard. So then I want to find the absolute value of negative 6.1. So again, that means how far is negative 6.1 from 0? And it's 6.1 away. So again, shortcut, if there's a negative value there, we change it to its positive form for the absolute value of that. So the absolute value of negative 3/4 is just 3/4. And then similarly, the absolute value of negative 1/2 is 1/2. So I'm going to put these on a number line. So again, when we're putting absolute values on a number line, it's always going to start from 0, because again, we want to know the distance from 0, and we're doing distances as positive numbers. So I need 1, 2, 3, 4, 5. Our biggest value that we're putting on here is 6.1, so I'm just going to go up to 7. So the first number I want to put on is the absolute value of 4.2, which is 4.2. So 4.2 is between 4 and 5. It's closer to 4 than 5. It's about there. So I'm going to call that the absolute value of 4.2. And then the absolute value of negative 6.1 is 6.1. So that's between 6 and 7, way closer to 6 and 7. So I'm going to put it there. And that's where the absolute value of 6.1 is. Next, I'm going to do the absolute value of negative 3/4, which is 3/4. So it's going to be between 0 and 1, and it's 3/4 of the way between those. So I'm going to put it there. And then the absolute value of negative 1/2 is 1/2. So that's halfway between 0 and 1, which is right here. And I'll label that right there. So again, if I'm writing these down in order from least to greatest, I just go from the furthest left number to the furthest right number here. So my order would be negative 1/2, negative 3/4, so the absolute value of those, the absolute value of 4.2, and then the absolute value of negative 6.1. So I am going to do the check your understanding number 2 on the next video. So please watch that.